Hello, calculus students. This lesson is going to be on finding limits numerically and graphically, or should I say graphically and numerically. So we're looking at 1.2. Basically, we're trying to estimate a limit using the numerical or graphical approach, and we're going to learn some different ways that a limit can fail to exist. One thing we can think about is if we look at this function right here, f of x equals x cubed minus 1 over x minus 1, where x is not equal to 1, obviously, since that would cause 0 in the denominator. Now the graph kind of looks like this. It's like a parabola, and at x equals 1, there's a hole in my graph. Okay? So this says, what is f of 1? So when we plug 1 in there, well, the answer is it does not exist because there's a hole in the graph. And we can look up here, it's not defined in the domain. So that leads us to another question. Okay, well, what does f of x approach as x approaches 1? And that should be a question mark at the end there as well, but that's okay. Well, there's a couple different ways. We can look at the graph, and we're pretty sure it's going to be 3. So that looks pretty good, but let's go ahead. We can make a table, and we use the calculator with the ask setting, and we can plug in some values, 0.75, 0.9, 0.99, 0.999. And as we do that, we notice that those y values, 2.313, 2.710, 2.970, 2.997, wow, that's getting pretty close to 3, it looks like. And then let's say, all right, that's sort of as we're inching along this way. Well, what about if we inch along from the other side? What if we march along like this? So I'll put 1.25, 1.1, 1.01, 1.001. So you can see I'm getting really close to 1. Not just 1.3, 1.2, 1.1, but actually inserting zeros in between here to really get really close. That's like a 10 times closer. And if we look at the y values, 3.813, I think that's 310, 3.030, 3.003, so we can see there's increasing zeros here. In fact, it's the y value, the f of x value, is also approaching 3 going this way. So we can confidently say that f of x approaches 3 as x approaches 1. If we do that in symbols, we write it like this. The limit of f of x as x approaches 1 is equal to 3. And that's how we could say that in words. The limit of f of x, say this whole top part first, as x approaches 1, so go down here to the next line, is or equals 3. So in class we will repeat this for another interesting problem. What happens as x approaches 0? You can see that actually if we plug in 0, then we get 0 here. Square root of 1 is 1, and we have 1 minus 1 in the denominator. There's no way that's going to work if we just plug in x. We're going to have to look at the table. So I got my x values, negative 0.1, negative 0.01, negative 0.01. We're getting closer to 0. And also over here, 0.1, 0.001, 0.01. And it's from the left and from the right, really looks like that y value is approaching 2. So the way we would write that out is the limit of f of x as x approaches 0 is equal to 2. So I'm just going to write f of x here instead of all that stuff. We also can find the limit of piecewise functions. So we've got two rational functions up there. Here the piecewise function, if you remember piecewise, it's in pieces. F of x equals 1 if x is not equal to 2. F of x equals 0 when x does equal 2. So here's what that graph looks like. It's always 1, except the y value is always 1, except when x is equal to 2. In that case, there's a hole and the value of the function drops down there. So the question is, what happens as x approaches 2? What's the limit? And the answer is, we can look at it here. Always, it's 1, 1, 1, 1, 1, 1, 1. Anyway, so we approach over this way. 1, 1, 1, 1, 1, 1, 1. And so we would say that the limit of f of x as x approaches 2 is equal to 1. There is a way to enter this into the calculator, this piecewise function. You say y1 is 1 divided by, which means sort of like when x is not equal to 2. And y2, you put 0 when x is equal to 2. You can't evaluate the limit on some of these calculators, but you can graph that. The problem is if you actually graph this, then on the calculator, normally you're not going to see that hole because it's going to be so close. Alright, so that's how you evaluate the limit. You can look at the graph and by looking at the tables. There actually are 3 situations in which we say the limit doesn't exist. I'm going to scroll back up here. Notice for this first problem, f of 1, the function didn't exist, but the limit did. The function was non-existent, but the limit of the function, we found out, was actually 3. This one right here, if you were to plug in, if we were to say what is f of 0, the answer would be does not exist, because you end up with 0 in the denominator. However, the limit of f of x as x approaches 0 was 2. So you have the idea of, okay, you can't directly evaluate the function at that point, but you can find what does it get closer and closer to as we're approaching from the left and from the right. Same thing here, except that actually we could say what is f of 2, and the answer is it's 0. It's right here. That's where the dot is. However, the limit of f of x as x approaches 2 is 1. So really want to highlight the difference between what is the function value and what is the limit as x approaches a certain value, the limit of that function. So there's 3 situations though when actually the limit itself doesn't exist, and here's the first one. It's when that behavior differs from left and right. So for instance, in this graph, which is the absolute value of x over x, you have a graph over here, and it's a piecewise graph, and you say what's the limit? Well, as we're approaching from the left, zip, oh, it's y value negative 1. As we're approaching from the right, right there, zip, it's 1. So, but it's approaching different things from different directions, so we would say the limit does not exist. Another situation in which the limit doesn't exist, since by definition the limit is asking what number are we approaching. If you happen to be approaching infinity, infinity is not a number. So, for instance, in this graph right here, which is the limit of 1 over x squared as x approaches 0, we would say does not exist. There's unbounded behavior there. So basically, if you have an asymptote and you're wondering what's the limit as x approaches that asymptotic value, then it does not exist. And that would be, it'd be, you know, sometimes you get one where the graph goes down here and it's sort of like, well, you've got 2 things. You have behavior differs from left and right. This one goes to positive infinity, that one goes to negative infinity, and infinity is not really a number. The third situation in which a limit doesn't exist is oscillating behavior. This is something we don't see a whole lot, but it does occur in physical situations. For instance, the sine of 1 over x. And it's hard to tell here, but actually, and we'll do this in class, when you zoom in on that, it just gets crazier and crazier. And it's really hard to tell exactly what's going on. The limit of sine of 1 over x as x approaches 0. There's a little note, the calculator may give a false answer on this one because it has to make approximations. The correct answer here is it's oscillating behavior. All right. Homework that we have set up 1 through 25 odd. That's a total of 13 problems. Let me know if you have any questions. Thanks for watching.